The airport was supposed to open in 2008. It is now 2025. $1.5 billion have been spent. 17 years of missed deadlines have passed. And the terminal, fully roofed, fully glazed, fully visible from the highway, has never processed a single passenger. Inside, the check-in desks are installed. The departure boards are mounted. The baggage belts are in place. Nothing moves. Outside, the runways are paved and painted. The taxiways are marked. The control tower stands fully equipped. On clear days, you can see the whole structure from 20 kilometers away. Massive, modern, and completely silent. The city around it has rebuilt itself twice since construction started. The airline routes it was designed to serve have already been rerouted elsewhere. And the government that approved it is no longer in power. Something went wrong here. Something deep. Something that a new deadline and a new director cannot simply fix. The question is not when this airport opens. The question is whether anyone still knows how. The decision to build begins with a problem that seems straightforward. The existing airport cannot grow. It was built in the 1960s on land that has since been absorbed by the expanding city. Residential neighborhoods press against its perimeter fence. The single runway cannot be extended. The terminal handles 11 million passengers per year. Its designed capacity is 9 million. Every peak travel day, the system is visibly failing. Gates are shared between arriving and departing flights. Baggage carousels operate in shifts because there is not enough floor space to run them simultaneously. Aircraft queue on the apron waiting for stand availability. Ground handlers work in conditions that repeatedly fail safety audits. Aviation consultants present the government with a clear choice. Expand the old airport, which is physically impossible without demolishing thousands of homes, or build a new one from scratch on open land outside the city. The government chooses to build. A site selection process runs for 2 years. 17 candidate locations are assessed. The chosen site sits 43 kilometers from the city center, far enough for noise separation, close enough for ground transport connection, flat enough for runways in 3 directions. Soil surveys are commissioned. Hydrological studies are completed. Environmental impact assessments run for 14 months. Every report comes back with broadly acceptable findings. An international design competition is launched. The winning terminal concept is dramatic. A continuous curved roof structure spanning 500 meters, with a central hall lit by a gridded skylight system. The design is published in architecture journals before a single contract is signed. The budget is set at $320 million. The opening date is fixed, the first quarter of 2008. Parliament approves the funding unanimously. One senator says the project will show the world what this country is capable of. He is right about that, just not in the way he imagines. Ground breaks in early 2003. The mobilization alone takes 3 months. Access roads must be built before construction equipment can reach the site. Temporary power lines are run across the open land. Water supply infrastructure for the batching plants is laid before the first cubic meter of concrete is poured. When the machines finally move, the scale is immediate and overwhelming. 62 pieces of heavy earth-moving equipment work across the site simultaneously. In the first 8 weeks, 6 million cubic meters of earth are moved, graded, cut, and redistributed across the runway platform. The ground is reshaped. What was farmland becomes a flat, engineered surface prepared to carry the weight of the largest commercial aircraft in service. Pile driving begins on the terminal footprint in month 4. The design calls for 478 foundation piles, reinforced concrete columns driven into the earth to transfer structural loads down to the stable rock layer below. Each pile takes between 4 and 7 hours to install. The work runs 6 days a week. In the runway zones, asphalt paving trains begin laying the first of 11 structural layers. The runway buildup is not a single pour. It is a sequence of precisely engineered layers, each with its own compaction requirement, its own thickness specification, its own curing period before the next layer can be applied. This process takes the better part of a year for each runway. Workers arrive on site before dawn. Concrete trucks line the access road each morning for hours. At peak construction, the site employs 5,800 people directly, with another 3,000 in the supply chain. The terminal steel erection begins in month 8. The first column rises on a Tuesday. By the end of that week, 30 columns are standing. Within 6 months, the primary structural frame spans the full length of the building. The distinctive curved roof, the feature that appeared in architecture journals, begins to take shape above the steel. Photographed from the air, the project looks like exactly what it was promised to be. Then, in month 11, a pile-driving crew on the eastern terminal section hits something unexpected. The drill string drops. Unexpectedly. Fast. The operator stops immediately and reports it. Nobody is sure what it means yet. Geotechnical engineers drill investigation boreholes around the anomaly. What they find ends the confidence phase of this project permanently. Beneath the eastern third of the terminal footprint, the rock layer that was supposed to provide pile-bearing capacity does not exist at the expected depth. It dips sharply, in some locations by over 12 meters below the design assumption. In between, the ground consists of alternating layers of soft clay and water-saturated sand. This is not a minor variance. It invalidates the foundation design for the entire eastern terminal wing. Every pile already installed in that zone must be assessed. 31 piles have insufficient bearing depth. They cannot support the structural loads above them. They must be extracted, a process nearly as complex as installation, and the zone must be redesigned before any new foundation work can begin. The foundation redesign takes 4 months. The solution is a piled raft, a reinforced concrete slab of significant thickness, post-tensioned, spanning between deeper piles drilled to the actual rock surface. It is structurally sound. It is also $44 million more expensive than the original foundation design. The project budget crosses $400 million for the first time. While the eastern foundation is being redesigned, surveyors conducting a routine check on the primary runway find a gradient error. Over a 300-meter section near the threshold of runway 24, the longitudinal slope exceeds the maximum permitted under International Civil Aviation Standards by 0.15%. The error originates in a leveling mistake during the sub-base compaction phase, a mistake that was not caught during intermediate inspections because the inspection intervals were too widely spaced. The affected pavement section must be milled off and relaid. That section of the runway is set back 8 months. With the eastern terminal delayed and the primary runway pavement reset, the project issues its first revised schedule. The 2008 opening is no longer achievable. The new target is mid-2010. Then the terminal roof structure reveals its own problem. Wind tunnel testing, conducted after fabrication had already begun on the steel roof members, identifies a resonance frequency issue in one section of the curved structure. Under specific wind conditions from the northeast, the roof section will experience oscillatory loading that the original design does not adequately address. Damping systems must be engineered and installed into already fabricated steel members. The roof contractor applies for a variation claim. It is valued at $19 million. 3 different problems, 3 different engineering disciplines, and the building is not yet enclosed. The project enters year 5 with a budget of $580 million and a schedule that structural engineers privately describe as optimistic. The eastern terminal foundation is complete, but the time lost in that zone has compressed the downstream schedule for all mechanical and electrical installation in the eastern wing. Ductwork, electrical conduit, fire suppression pipework, and data cabling, all of which require the structural frame to be complete before they can proceed, are now being rushed to recover lost time. Rushed installation creates its own problems. A fire suppression system installation audit finds that 17 sprinkler zones in the eastern departures level have been installed with incorrect pipe sizing. The pipes are too small to deliver the design flow rate. The system will fail its hydraulic performance test. 17 zones must be stripped out and reinstalled. At the same time, the baggage handling system contractor, brought on board 2 years earlier under a fixed-price contract, formally notifies the project authority that the eastern wing foundation delay has changed the physical geometry of the baggage routes in ways that require contract renegotiation. Their original design assumed straight conveyor runs from check-in to sorting. The revised foundation layout introduces column positions that obstruct 3 primary conveyor paths. The baggage system must be rerouted around the new columns. The contractor submits a variation claim for $31 million and a 12-month program extension. The project authority disputes the claim. Legal proceedings begin. For 14 months, the baggage system installation in the eastern zone stops entirely while the dispute runs through arbitration. The budget crosses $700 million. A parliamentary oversight committee convenes its first hearing. The transport minister faces 4 hours of questioning. He defends the project. He commits to a 2012 opening. 6 weeks after that commitment, the runway lighting contractor goes into receivership. The secondary runway lighting installation is 40% complete. The insolvent contractor's equipment is on site. Their workforce evaporates within days. Finding a replacement contractor who can take over a partially complete installation, using another firm's equipment and documentation, takes 9 months. The 2012 opening date is abandoned before it is ever formally endorsed. The budget crosses $900 million. No new opening date is announced. In the project's 9th year, the National Audit Office publishes its findings. The report is 240 pages. Its conclusions are not qualified. $610 million of the $890 million spent to date cannot be verified against certified completed work. 43 contracts were awarded outside competitive tender procedures without documented justification. One structural concrete supplier provided material over a 7-month period that failed independent compressive strength testing, and the test results were received, filed, and not actioned by the project's quality management team. The concrete in question is in the terminal's ground floor structural slab. Core samples are taken immediately from 42 locations across the ground floor. 19 samples fail. The affected area covers 6,200 square meters, the central check-in hall, the primary security screening zone, and the main passenger circulation spine. These are not peripheral areas. They are the functional core of the terminal. Structural engineers assess the risk. Their conclusion is unambiguous. Under sustained dynamic loading, thousands of passengers, baggage trolleys, service vehicles, the substandard slab presents a long-term structural integrity risk that cannot be managed through monitoring. It must be removed. The terminal's most complete section must go back to bare structure. 3 days after the audit report is published, the transport minister resigns. The project director is suspended pending investigation. 2 senior engineers in the quality management team are placed on administrative leave. The government freezes all non-essential construction expenditure on the site. Work stops on 6 of the 9 active construction fronts. The site, which once employed nearly 6,000 workers, retains only a skeleton crew for security and essential maintenance. International media runs the story. The images are stark. An enormous terminal building. Empty. Silent. Cranes stationary. Access roads deserted. One wire service describes it as the most expensive unoccupied building on Earth. That description circulates for years. 11 months after the shutdown, a new legal entity takes control. The National Airport Delivery Commission is established by emergency legislation. It has direct treasury access, independent audit authority, and a mandate with no political interference clause. Its chair is an engineer who previously recovered a collapsed highway project in a neighboring country. Her first public statement contains no optimism. It contains only a method. Assess everything. Fix what is fixable. Demolish what is not. Sequence correctly. Test before proceeding. The ground floor slab removal takes 8 months. Diamond wire cutting. Controlled demolition in sections. Temporary shoring throughout. The structural frame above is preserved. The substandard concrete is removed without damaging a single column. New concrete, specified, tested, batch certified, and independently verified, is poured in sequence over 14 weeks. The baggage arbitration is settled. The project authority pays $23 million. Installation resumes. The Eastern baggage system comes online internally for the first time in year 13. It immediately fails its first integration test. The baggage destination readers, optical systems that read bag tags and route luggage to the correct carousel, are incompatible with the updated baggage management software installed during the shutdown period. The hardware and software are from different generations of the same platform. Either the hardware must be replaced or the software must be rolled back. Rolling back the software removes security features required under post-2015 aviation regulations. The hardware must be replaced. Another 8 months. Another contract. Another delay absorbed into a schedule that has stopped being measured in years and started being measured in problems remaining. A phased opening strategy is proposed for the first time. The Western Terminal, structurally clean, mechanically complete, baggage system operational, could open for domestic flights while Eastern Terminal construction continues. A test mobilization is conducted. Ground handlers train on the systems. An airline is identified as a launch partner. A domestic route is nominated. 3 weeks before the phased opening date, the airfield lighting control system fails its final certification test. A software integration fault causes the approach lighting sequence to drop out under simulated low visibility conditions. The certification authority will not issue approval until the fault is fully resolved and retested. The phased opening is postponed. 22 years, $1.5 billion, and the final number is still being calculated. The western terminal is functionally complete. The runways meet certification standards. The control tower is operational and staffed. On most systems, the airport works. On the systems that matter for certification, something always remains. The airfield lighting fault is under active repair. The eastern terminal baggage system is in final commissioning. The phased opening has a new date. It has had new dates before. What this project has taken cannot be recovered. The airline hub that was supposed to anchor the airport's commercial future is operating out of a competitor city 400 kilometers away. The economic modeling that justified the original investment assumed an airport open by 2010. Every year of delay has compounded a loss that no opening ceremony will reverse. The old airport is still running, over capacity, every day. And somewhere in the silent eastern terminal, in a building that cost more than the GDP of some nations just to reach this point, engineers are still working, still testing, still correcting, still finding the next thing that must be fixed before the one after it can begin. The airport may open this year. It has been about to open for a long time. The real question, the one that nobody in the Commission or the Parliament or the Ministry wants to answer directly, is simple. If it took 22 years and $1.5 billion to almost finish it, what exactly did they think they were building?